Hi everyone, we are from Weltech University, Dr. Rangarajan Saguntala and R&D Institute of Science and Technology, Department of Computer Science and Engineering, School of Computing, and this is our major project and internship through DIN Connect You. Our project title is Dynamic Object Detection for Smart Farming using Drone Technology, and our supervised by Dr. D. Umanandani, Professor, and presented by Kunal Rakesh. I'm Kunal Vignesh, myself, and this is our industry details. And this is the agenda, like abstract, objective introduction. What are the key terms included in our project? And this is our abstract. And dynamic object detection for smart farming using drone technology is an innovative project that aims to revolutionize traditional farmer practices, like by combining advanced computer vision, and we are developing this drone technology object detection project, and we utilizes the YOLO algorithm in this project, and for its efficiency in real-time object detection, and like drones equipped with high resolution cameras provided, like we are using like uh, module drones, and allowing like farmers to monitor crops, weed pests, and environmental condition effectively. So this is the real time things. And for furthermore, our project not only enhances operational efficiency but also promotes sustainable in agriculture. And ultimately, the dynamic object detection technology represents a approach to agriculture innovation and combining technological advancements with a commitment to sustainability for the betterment. And these are the keywords of our project, like dynamic objects, smart farming, disease detection, drone technology, YOLO algorithm, precision agriculture, and data driven, etc. And these are the objectives and aim of the project. And its technology to transform tradition. Like in this, the integration of smart algorithm and user interface, friendly and ensures seamless experience for farmers, contribute a and efficient future for agriculture. And these are all about introduction of our project. And this is our prototype of our drone. And you can see like flight controller and like Raspberry Pis and some GPS tracker displays and everything. And this also some bit description of our introduction. And you can see below the drone spraying to the crops. And this is our literature review. We have collected like 10 papers, and this the design methodologies and the process of food. Project begins like data collection and next to like objective modeling in integration technology, like a real-time data transmission, and coming to more user development and user interface, the real and these are the process of project, how get the data and give the insights to the information part, like four pie diagrams like architecture diagram, data flow diagram, ER diagram, sequence diagram, and collaboration diagram. And these are the implementation steps of the project. And first step, like the setup in the development environment. And next started the training. And next integration with drone technology, user interface development, system integration, alert system implementation, testing and debugging, optimization, documentation, deployment, and everything you can see in the this is the architecture of the diagram, like Raspberry Pi. You can see the Raspberry Pi, props and plans, and everything is interlinked. And we have used complete, step by step process, like pre-processing Raspberry Pi, disease detection using machine learning algorithms, image processing, data transmission, storage, and finally we can see output in the ground station. And this is the explanation of it. And coming to the data flow diagram, this is how the project flow step by step, like data flow diagram. And these are the year diagram, entity relations with the above one. Like this is the sequence diagram, how the project runs like in a sequence, image-based past data, tuning model, classify plant disease, and some Python DNAME frameworks. And this is the sequence how the project runs, and this is the explanation of the diagram. And coming to the last collaboration diagram, this is one start disease detection test like accuracy, medication spray, and this is explanation of this diagram. Now the technical testing, functional testing, and white box and black box testings. This is a testing. Like I have some, you can see some pseudo kind of code over here. So that is the test results and integration testing, like object detection uh, for communication encoding data to drone. Like this is the functional testing. Like you can see some pseudo code, like I'm encoding some packages from Python libraries for the object detection. And this is white box and black box. And this is the input and output results. And we gave like a sample kind of crop, and with the help of drone, we have taken the picture of that defective crop, and you can predict the output of that crop, like what are the defects of the crop and how can we prevent those kind of diseases. You can see like I've taken the crop tomato, and like it will show that disease and cause of diseases and everything. So this is how the output comes from our project. And you can see like this is the website which you can see our condition of the plants. And now the implementation and coding part will extend my friend Rakesh. He continue the coding part.
This is Rakesh. I'm going to show you the expansion part, the demonstration of the project. So I'm connecting the Raspberry Pi now. In the from the SSH client. Eyes. So I'm connecting to the display. I'm using real VNC view for display. This is the display of the Raspberry Pi. The Raspberry Pi is connected to the drone. So now I'm running the project. I'm going to the drone folder. Running now. It's our project. I'm going to show the app.py file code. So here is a code. I'm going to expand this. So we need to import the necessary libraries. Importing necessary libraries such as the Flask, Pandas, Keras, and Pickle, and model loading the data manipulation. And coming to the model loading, it loads a pre-trained Keras from trained model 5, and pest classification and Pickle model 5 crop recommendation for the crop recommendation. From Flask installation, the Flask app will be installed. And the fertilizer recommendation, when the user submits the fertilizer related information, crop name, nitrogen, phosphorus, potassium, via form, it calculates the required fertilizer based on the differences between the desired and field nutrient levels. Pesticide predictions, the pesticides route handles the prediction of pests based on the image uploaded by the user. It uses the pre-trained Keras from the classified pest. From crop recommendation, the crop prediction route handles the prediction of crop based on the environmental factors such as nitrogen, phosphorus, potassium, pH, rainfall, temperature, and humidity. And routing to the different HTML templates which are in the files in the templates. Like of crop recommendation is .html, fertilizer recommendation .html, pesticide recommendation .html. The files are stored in the templates. And running into templates like index.html, crop recommendation.html, fertilizer recommendation.html, and pesticide recommendation.html. And coming to the static files, here are the static files. Image predictions, predicted crop served by statical from the static directory. And server installation, the server is run with debug mode enabled. This application serves a platform when users can get recommended from crops, fertilizers, and pesticides based on the inputs and uploaded images. It utilizes the machine learning models. Pest classification and crop recommendation along with basic logic fertilizer recommendations. And I'm going to show the demonstration of the project now. And it's running. So coming to the crop disease now. I'm choosing the image which is detected by the drone, which captured by the drone. This is one of the image which captured by the drone. So the file was uploaded into it. I'm going to predict now. So here is the details. Crop is a tomato disease, late blight. Late blight is a potentially devastating disease of tomato, infecting leaves, stems, and fruits of plants. And disease spreads quickly into the fields can result in the crop. So these are the results which given by the project. So these are the sample test of this project. And one more, I will show the one more sample. So recommendation about the types of fertilizer best suited by the particular soil are recommended. Here is the sample. So nitrogen I'm taking as a 10 value. So I'm using a phosphorus as a 5 and potassium as a 7. And crop I want to grow. So I want selecting as rice. So I'm taking a predict. So it's given the details of information what the requirements I need to take of the crops in the soil. So these are the things. And coming to the part, coming to the one more part of crop recommendation, in which area, which crop I need to grow. So I'm taking nitrogen as a 10 and phosphorus 5 value and potassium is 7. P and pH level as 4. and rainfall is a 5 millimeter. pH value is a 7. I'm telling state as Tamil Nadu. City Chennai. I'm selecting the city Chennai. So it recommend which crop I need to grow. So you should grow the mud beans in your farm. This is our project. So I conclude that dynamic orbital decision for smart farming using drone technology has successfully implemented a real-time solution and combining advanced computer vision with the drone capabilities. The integration of the YOLO algorithm provides the farmer with the instantaneous insights into the crop health, pest presence. So overall, the field conditions with a user-friendly interface, the system facilitates the easy monitoring and historical data analysis and prompt alerts, empowering farmers to make informed decisions. This project not only enhance the efficiency in individual farms, but also contributes to broader goals of sustainable and resource-efficient agriculture. The successful deployment signifies the transformative potential of technology in shaping a more resilient, data-driven future of for farming practices. Thank you.